Atlantic Canada doesn't often make the short list when people talk about the future of energy. But that's about to change because Atlantic Canada has wind, and we have a lot of wind. It blows hard and it blows steady off the ocean and across the land. But for most of our history, the wind was just weather. It was something you dressed for or something you complained about. But now we're starting to see wind differently as an opportunity because that wind can generate renewable electricity to power vehicles, heat buildings, and run factories. And that same electricity can feed an electrolyzer to produce green hydrogen, which is where the story gets really interesting. And the most interesting part is the people writing that story. And that's the story we're here to tell. Atlantic Canada's Hydrogen Future is a podcast about the industry leaders, energy experts, innovators, researchers, and policymakers who are writing the next chapter of our region's energy story. They're the people doing the work to build a thriving low-carbon hydrogen sector in Atlantic Canada from the ground up. I'm Derek Estabrook, Executive Director of the Atlantic Hydrogen Alliance and your host. Today, we're heading to Dalhousie University to speak with Dr. Mita Dasog and Dr. Michael Freund, the co-leads of the Dalhousie Green Hydrogen Research Cluster. Founded in 2022, the cluster was set up to identify, organize, and mobilize academic expertise in support of Atlantic Canada's emerging hydrogen economy. Its mission is to bring together researchers, industry partners, NGOs, and government to build world-class green hydrogen R&D capacity right here in Atlantic Canada. In just its first 3 years, the cluster has already grown to more than 30 researchers across 8 faculties working on 10 research projects. It has established 6 partnerships with industry and 5 international collaborations. The cluster has already secured nearly $5 million in research funding and published 60 peer-reviewed papers on hydrogen technologies and systems. That is a pretty remarkable launch. So Mita and Michael, I'm really looking forward to our discussion today about the Dalhousie Green Hydrogen Research Cluster. So before we get into the cluster's work, I'm curious to hear a bit about what drew you to green hydrogen research and about your core research interests. Mita, could you start?
Thank you for having us, Derek. So I've actually been interested in green hydrogen for more than a decade, since my Caltech days, actually, and before hydrogen was the buzzword it is today. And what got me interested in hydrogen was the versatility of its use. It is important not just from an energy storage and production angle, but it is also very important chemical feedstock that can help decarbonize the chemical industry. So I joined Dalhousie in 2016. I'm currently here working as an associate professor and also as a Canada Research Chair in the Advanced Materials Water Energy Nexus. So my group here mainly focuses on many green hydrogen production technologies. And more importantly, how can we help bring the production costs down and the cost of hydrogen down? Now, for water electrolysis, our group is trying to find catalysts that are cheaper, more abundant, and materials that are not susceptible to the supply chain issues. But we also look at alternative technologies to that of electrolysis, technologies like artificial photosynthesis, which are less capital intensive compared to electrolysis. So really across all of this work, our goal really is to design materials that are durable, high performing, and affordable.
Interesting. Well, I hope we're going to be able to dive into a few of those topics during this podcast. So, Michael, can you tell us a bit about your work and your primary areas of focus within the hydrogen ecosystem?
For sure. Thanks for including us in this podcast. My group really has been interested in hydrogen for quite a long time through water splitting. So we collaborate a lot with Mita's group, and we're focusing on the electrolyzer, basically the heart of the technology required to convert electrical current into green hydrogen through the splitting of water. While the reaction seems very simple on paper, it's an incredibly difficult balancing act to create an integrated system that manages the movement of electrons and ions and the catalysts involved in the overall process to generate the green hydrogen. The holy grail for us is to develop systems that don't rely on the costly, rare materials that are currently used, and to move to a more sustainable and deployable technology based on earth abundant chemicals.
Interesting. Well, and this issue of cost is really critical because one of the biggest challenges that we face in the hydrogen sector is reducing the cost of green hydrogen produced through electrolysis so it's more competitive with other forms of renewable energy. So great to hear that you're focused in that area. Let's kind of switch gears. So the cluster has more than 30 researchers collaborating across 8 different faculties, which seems like a pretty remarkable organizational achievement. Mita, can you tell us a bit about how you get researchers to collaborate across these really diverse fields like science and agriculture on a very specific subject like hydrogen?
So when we think about hydrogen, it becomes very clear that it's not just a chemistry challenge. It really is a systems challenge and in many ways a societal challenge. So if we want this transition to be successful, so we will need physical and environmental scientists, engineers, economists, social scientists, really all of these people working together, looking at everything from production to infrastructure to end use and how it integrates within the society. So when hydrogen started to gain attention in Atlantic Canada, Michael and I first looked within Dalhousie to identify what expertise we had in-house. And we quickly realized that there's a lot of relevant knowledge that's spread across many different faculties, from science and engineering to agriculture and management. So, and with the support of partners like Net Zero Atlantic and Atlantic Hydrogen Alliance, we actually engaged with industry and government to understand what their priorities were, what their challenges were. And that really allowed us to map our academic strength onto these regional needs. So in the early years of the cluster, we focused quite heavily on bringing people together. We organized workshops and meetings between researchers, industry, and policymakers to really help establish those connections and build trust. And once people understood what others were working on, the collaborations kind of started to form naturally. And so today, the cluster really allows the researchers to self-assemble around emerging opportunities or challenges that come up. And our role really is to keep our ears to the ground. And, if there's any larger initiatives that need to be taken, then we can really rally the right people around that and move very quickly to help address any challenges or opportunities that come our way.
Interesting. Well, I'm really glad to hear that you're doing that because I think sometimes we kind of fail to understand the complexity of the energy transition. That's not just about technologies. If it was, it would be relatively straightforward, but it isn't. It's about kind of behavior change and getting, building this social license that's required to develop the projects. And there are political implications and regulations and codes and standards. And only when you can kind of figure all of that out together can we kind of successfully transition the energy system to where we're trying to get to. So great to hear. Michael, I want to dive a little bit into some of the research pillars that the cluster is working on. Their work is organized, as I understand it, into kind of 3 main pillars. One is hydrogen production technologies, and then supply chain assessment and safety. So let's dive into these pillars. And I think I want to focus on production technologies, because in your introductions, you both talked about that and the importance of looking at new ways to produce green hydrogen, especially ways to lower the cost. Maybe, Michael, tell us a bit about why you identified hydrogen production as a research priority, and maybe tell us also a little bit about some of the promising areas that your team is pursuing.
Sure. Well, the technology really is the bottleneck based on cost, as you said, which then impacts widespread adoption. So when I talk to people about this, I use solar energy development as an analogy. We've had the technology to do it efficiently since the space program. That's hydrogen electrolyzers and fuel cells, as well as solar energy conversion. In terms of adoption and widespread use, it really all comes down to cost per kilowatt hour. And with the breakthroughs around solar, now you can't drive through a neighborhood without seeing solar on a roof. So it's everywhere. And I think that, green hydrogen is kind of in a position to make a similar transition as long as we can really tackle some of those key bottlenecks. Some of the promising areas really is to address availability and stability of the key components that are part of the electrolyzers. I mentioned about it already that it involves precious metals, for example, and a lot of other materials that are high cost. And that's fine for submarines and for spacecraft, but for widespread adoption, we really need to address that. So one of the promising areas we're pursuing right now is looking at earth-abundant elements for the catalysts, as well as the other materials that go into the electrolyzers. We're also focused on supply chain adoption, what makes sense to Atlantic Canada. And of course, safety is an issue all along the value chain, from production to utilization and storage. So those are the primary promising areas that we're focused on.
In our work at the Atlantic Hydrogen Alliance, one of the challenges we often face is building this supply chain. Because unlike electricity, where we've had the supply chain for 150 years or more, we already have the technologies to generate electricity. We have wires, we have batteries. Every home already uses electricity. So electrification just means expanding that. Where with hydrogen, the supply chain for the most part doesn't exist yet. And in order to be successful, you've got to be able to build out the entire value chain. So really kind of build every link of the chain simultaneously before you can actually start producing and using hydrogen at scale. And that is very difficult to do. And it's expensive too, because you've got to invest all the capital required to build out all of that infrastructure. Let's move on and talk about partnerships. So I know partnerships are really important for the cluster. I heard that you've already built several productive industry partnerships, including the Hydrogen Applications Research Lab with Eastward Energy and other partners. So what does that partnership look like? And how do these partnerships help bridge the gap between fundamental research and real world applications?
Well, I think they're absolutely essential. Professor Michael Pegg's application lab that you mentioned is perfect example of that. It's really addressing the interests of companies like Eastward Energy. They're highly motivated to decarbonize the natural gas industry through blending of green hydrogen with the natural gas. These transitions are take time and they're gradual, and it requires updating related technologies, for example, burners that are used in households, as well as creating standards and ensuring safety during deployment. So it's really key to interface between the labs and industry. We're also working with other industries, including producers of ammonia. You're probably familiar with the fact that ammonia is a key fertilizer and feedstock in industry. And it's typically made from fossil fuel derived hydrogen, which is incredibly carbon intensive. So these new industries are highly focused on producing clean ammonia from green hydrogen and nitrogen from the environment. And they're investing in existing technologies to do that. But they've done the math and they recognize the huge capital investments, as you mentioned, and how a breakthrough in the sort of technologies that we're talking about in terms of cost of the compounds involved would be a huge breakthrough. So now these projects are very on a very large scale because that's who can afford it. We're also engaging municipalities to explore how hydrogen might make sense currently and in the future. There's a lot of interest in transportation, which is actively interested in decarbonizing their sector as well.
Right. And the Atlantic Hydrogen Alliance is starting to do some work in that sector, specifically with heavy transportation. We know that in the passenger and light duty vehicle market, battery electric vehicles probably will be the preferred technology. And we're already well down that path. But when it comes to decarbonizing heavy transportation, whether it's big long haul trucks or buses or trains or ships or even airplanes over the longer term, we're likely going to need other technologies in addition or instead of batteries, and hydrogen and fuel cells can play an important role there. Mita, let's bring you back into the conversation here. On the global stage, it seems like China and Germany really stand out as your research cluster is leading international collaborators, and they're certainly doing a lot of work already in the hydrogen sector. What do you think Atlantic Canada can learn from these hydrogen leaders? And so what does Dalhousie University kind of offer to those countries as you develop those relationships?
I think from an academic perspective, our collaboration started out mostly about, focusing on advancing the science because teams of multiple teams with complementary capabilities can do this faster than individual or teams can right now. And time is of the essence. So this really avoids duplicating efforts. So in doing so, we are already sort of informing each other about, be it in the space of materials development, on blending, combustion, supply chain modeling, what's working, what's not working, so we can sort of move together. But like you said, both countries, China, Germany, and a lot of other ones that we're working with have also invested quite heavily in hydrogen research. In some ways, are a little bit ahead. So I think they offer very valuable lessons about how technologies evolve from this fundamental discovery that's being done towards more mature and reliable systems. And I think for Atlantic Canada, one of the key things we can learn from this is how do we design hydrogen systems that are durable, safe, and scalable, but also work for our geography, right? So it's not just about duplicating what these other countries are doing, but sort of learning what's working, what's not working, and how can we translate those technologies, those lessons to our region. Does that work here? I think these collaborations also highlight the importance of coordination across the whole ecosystem that we discussed previously. I think, just not just from research, but, our researchers talking to industry and policymakers. What are the safety aspects around the technologies that are being developed? What is the workforce training look like and deployment look like? So I think these countries are showing us how to have those conversations effectively to make sure that we can accelerate this progress. I think what Dalhousie brings to this is a strong fundamental research in areas like catalysis, electrolysis, and a lot of really emerging hydrogen production pathways. We also have researchers working on blending that Michael discussed, transport and safety, case studies examining where hydrogen makes sense in Nova Scotia. And there are places like Nova Scotia in other parts of the world as well, so they can definitely learn from our case studies. And I think a core part of this contribution is training highly qualified students and researchers who will support the growth in the field. They're working in our labs. We have mobility programs, so they're able to go work in other labs as well and see, how the technology is being developed and deployed there, so they can bring that knowledge back. So I think these international collaborations really help accelerate new technologies. Like I said, because time is very important. So I think we collectively need to work together right now than compete with each other, especially in time of limited resources as well.
One of the things I find really exciting about what Dalhousie is doing is that, unlike solar or wind, which are more developed technologies, and work's been happening for 25 years or more on those technologies, where hydrogen and especially electrolysis is really emerging now. It's not that the technology hasn't existed for a long time, but we haven't put a whole lot of focus on it. So I think it is a unique opportunity for universities like Dalhousie to get out at the forefront. And people might ask, well, like, why Dalhousie? There are lots of places around the world where this research could be done. And I guess what I think about is, why not Dalhousie? We have the research expertise. You have academics. You've got provinces in Atlantic Canada that are really interested in developing the hydrogen sector. So why not here? And so I think it's great that Dalhousie is taking the lead in this area. Let's move on and go beyond the research itself, because I know one of the other priorities for the research cluster is around capacity building. So, Michael, can you talk to us a little bit about why this hands-on training is so critical at this stage of the hydrogen sector's development?
Well, I think, developing a deep understanding of new technologies, is really critical to facilitating adoption. And it requires, hands-on training for sure. And this ranges from, technicians and certification through our strong community colleges in Nova Scotia, as well as training of university students, undergraduate and graduate, really to develop a deep understanding of the technology, where it's going, as well as a broad understanding of where the technology fits into the wider energy landscape in Atlantic Canada, the country, and the rapidly evolving global economy for sure. One of our current initiatives is an NSERC-funded collaborative research and training experience program. It's called an NSERC Create, which is a multi-year funded program. And it really builds upon our existing expertise in science and engineering that you mentioned. I would just note that Dalhousie is ranked one of the highest in terms of both combined materials expertise and energy expertise. So I think we're very unique in that space. But in this program, we're covering all sorts of energy technologies, including green hydrogen in particular. The students get to interact with top researchers, government policymakers, industry leaders. They visit key sites involved in the energy value chain, the green hydrogen value chain, and learn what industry is currently doing, because they're really paving the way. Companies like Eastward Energy, they're really leading the way to integrating green hydrogen. So our students through this training program really get exposed to that. They also learn from social scientists and business experts on social acceptance and technoeconomics. And these trainees really represent the future leaders of our energy transitions. And so they're incredibly important, and they're really snapped up quickly by government and industry. So I think really, this area is critically important in terms of capacity development through universities.
I would agree with that. And I think that capacity building is a really important part of the hydrogen ecosystem. If you look at the oil and gas sector, for example, Alberta is not only the province where a lot of the oil and gas production happens, it's also where a lot of the R&D happens. And so they very much are developing an entire ecosystem around the oil and gas sector in that part of Canada. So I think it's really smart for us to be looking at Atlantic Canada not only as a place that can produce green hydrogen, either for export or for domestic use, but really building out all of the other parts of the ecosystem as well. So let's maybe wrap up here by looking back, and then let's spend a minute and look ahead too. So the cluster has been around for 3 years now, and as it enters its 4th year, tell me what you've learned about the unique opportunities and maybe also some of the real challenges that's facing Atlantic Canada's hydrogen economy, and maybe kind of some of the things that perhaps weren't obvious 3 years ago, or maybe were a bit overlooked back when you started.
Well, I would say, that basically the economy and politics has really been changing quite rapidly. So it's something that's very hard to predict. So one of our lessons learned really is that the economy and the priorities, both, regionally and nationally, are really a moving target, especially on the energy side, with the war in Ukraine, new administration south of the border, and now uncertainty associated with, hostilities in the Middle East. Our leadership and our priorities are naturally reactionary. And with the uncertainty, it's difficult to be strategic long term, especially with emerging technologies, because all the focus is on existing technologies and their cost and their integration. So it's been very challenging for us to really engage at a level that's required to have a major long term impact. As you said early on, it does really require investment and a long-term vision. And so I find that we're really competing with a lot of interests, and a lot of those interests are really immediate and understandably so.
Mita, do you have anything you want to add?
Yeah, maybe I'll comment more sort of looking ahead. I think it's fair to say that hydrogen is now moving from sort of the hype phase into more realistic phase. And for me, that's actually where the work becomes most exciting because we are moving from hypothetical situations to solving real technical challenges. And like Michael said, like on global stage, it is becoming more and more clear that we need to be self-reliant, especially when it comes to energy. So I think for researchers now, the priority is to bring that cost down. So how do we develop materials and ultimately systems that are cheaper and reliable? We also need to develop accelerated testing protocols that help transition these emerging technologies from bench scale to larger scale so we are able to deploy them faster. But even taking a broader lens to this, we talk about hydrogen supply chain, but also when we talk about materials that go into technologies that are making hydrogen, there's also supply chain issue there. So now as we develop these, we have to also consider and think about, okay, where are those materials coming from? Where are they being mined, refined? And how do we make sure, nationally, that we develop things that aren't going to be susceptible to these supply chains moving forward. So adding that another lens to it is becoming important, and it's been a quite interesting space and thing for us to consider. And another critical factor is public acceptance, which unfortunately is still a bit low in certain regions. So that's informing us and telling us that we need to communicate more clearly about what hydrogen can do, what it cannot do to demonstrate safety, reliability, environmental benefits in a more transparent way, in a more accessible way. So I think because public confidence will ultimately be just as important as any technical progress we are going to make. So that's definitely on the cluster's radar and something we hope to work on moving forward. We're also entering a very strategic phase. Now, I know there's a report being released very soon on hydrogen supply chain in Atlantic Canada. And I think that will be important because that will definitely help guide our next steps and identify where there are some strong opportunities and as well as gaps that need to be addressed. So I think a lot to consider, and I think a lot of new and exciting things happening and for the cluster members to focus on.
Wow. It sounds like both of you are going to be really busy over the next few years. So, Mita and Michael, thanks for joining me on the podcast today. And if you've enjoyed this conversation, I encourage you to subscribe to Atlantic Canada's Hydrogen Future, wherever you get your podcasts. And we'd love to hear your thoughts. So you can connect with us on LinkedIn, or you can learn more about the work of the Atlantic Hydrogen Alliance on our website at atlantichydrogen.ca. Thanks for listening.